vamos a retomar el ciclo de Prehistoria en Vivo. Es un ciclo que se ha desarrollado durante unos cuantos años hasta que comenzó la pandemia y pues el director del instituto ha considerado que era pertinente retomar esta serie de conferencias de manera presencial. Y en esta ocasión pues tenemos con nosotros a Chanteraud. Claire es doctora por la Universidad de Saboya, en Francia, y en estos momentos está desarrollando un trabajo postdoctoral en la Universidad de Missouri, en Columbia, en Estados Unidos. Fundamentalmente está trabajando sobre la caracterización mineralógica de óxidos de hierro, tanto naturales como de contextos arqueológicos, para conocer la gestión de estos minerales por las sociedades, en este caso paleolíticas, y en relación además con cuevas decoradas. Ha trabajado especialmente en la cueva de Grotte Point, que es una cueva que se sitúa a unos 10 kilómetros de la cueva de Chauvet, y es allí donde han desarrollado todo un sistema de análisis precisamente pues para conocer cómo es esta gestión de materias primas de óxido de hierro por las sociedades paleolíticas. En estos momentos, en su trabajo postdoctoral, pues ha saltado del sur de Francia al norte de la península ibérica, y es lo que nos va a presentar el día de hoy, ¿no? Este proyecto que acaba de comenzar en septiembre, se ha incorporado en septiembre del año pasado, del 2021, en Estados Unidos. Entonces pues lleva unos pocos meses de trabajo y estará allí hasta cumplir dos años. La conferencia será en inglés. A la hora de realizar preguntas pues las podéis hacer en castellano si queréis, porque las podrá comprender, o si no, pues ya lo traducimos, ¿vale? Y sin más, pues os dejo con Claire. Claire.
Muchas gracias, Diego. Well, I will speak in English. I'm very sorry for that because my Spanish is very bad. So, as Diego said, I'm coming from the US because I'm doing my postdoc there, and I'm working on the coloring materials that was used during the prehistoric time, and I'm working with Brandy Lee MacDonald. And if you don't know her, I really encourage you to go on Google or Scholar to read her paper because they are very good, and she developed a very good methodology on this kind of analysis. Well, that's my PhD. Sorry, I introduced myself a bit. As Diego said, I did my PhD in the University of Savoie-Mont-Blanc. That is in the east part of France, and I worked on the Points Cave, where there is some painting and drawings on the walls, and most important thing, there is coloring materials in the archaeological sequence that was linked to the Gravettian culture. So the aim of my PhD was to link the archaeological sequences with the painting on the walls. Actually, it's very difficult to do that because there is a lot of parameters that I have to take into account when I analyzed this kind of materials, like ochres and all of kind of rocks. And then this brings me, after my PhD, to Missouri because my supervisor, Brandy, she's working there as the assistant professor, and she gave me a scholarship there. So I am in contract. In this facility, it is a research reactor, so there is a nuclear reactor in the facility. It's here, and it looks like that. It's a small reactor, and we can put in it some powders and some samples to activate them and to analyze them, to have a geochemistry signature of the samples. And this kind of analysis is very destructive because after that, you cannot get your sample back. You have to put them in a cave because they are highly radioactive. So I will not do that on the archaeological sample, but there is a lot of other techniques that are available there, like ECM, EDS, like ECPMS. And if you have questions, don't be shy and ask me what it is if you want. So I am in this lab, and I am here because there is a question about how the ancient society gets the coloring material, how they transport it, and where. How did they transform it, and how did they use it? So it's all this operative chain. It's like chaîne opératoire. I don't know if you are familiar with this concept. So it goes to the supply of the materials to the use. And what I am trying to do is to reconstruct this, all these steps of the material. Before it, there is something very important. It is how the rocks is formed by nature and how it was transformed naturally. And it's called the evolutive chain of the materials. And it's quite important because the rocks are not in place, like in the outcrops, but they can move in the landscape and be available in multiple places. And after the operative chain, there is something going on the archaeological sequence and on the walls that we used to call tafonomy, but I'm not really sure it's the good word to speak about that, but it's the word I choose here. And it's what happened when the material are deposited on the walls or in the sediment. And there is many things happening, like physics changes of the materials and stuff. So it's all these changes I have to take into account when I am working on materials. So my question and my work is to link rock art sites, here that I put in red, with all the area where the materials, the coloring materials, are available. And it is not like there is not a point where there is one kind of material, is that the rocks are spread around in the landscape. And I try to question where it was available, which kind of material is available, and what was selected in the past to create rock art. So I hope I'm clear, and feel free to interrupt me and to ask questions. We are here to discuss. Okay, so my methodology, something very, I think, usually in archaeology, it's to go back and forth several levels of analysis. So when we are talking about archaeological sites, we can go from the residue, the pieces of archaeological whatever, to the sediment, the tracks, corpus, the section, and the region. I work at all this level, and I'm going back and forth to the consummation, transformation, and acquisition, and questioning all this interaction of, between human and materials to reconstruct this operative chain. In this axe, I have the, how can I say it? It's the method, the analytical method I use to describe the material and what is this specificity of the material. It's kind of like the mineralogy, the geochemistry, the macromorphology of the rocks, and on and on. So I'm going back and forth all these steps. Then. Okay, so it's just a little slide about why I'm here in the north of Spain. It's mostly because there is a lot of caves, rock art caves, and by the work of the different archaeologists here, we have many pieces of coloring materials in archaeological context. That it is very good to work on cultural practice during the Palaeolithic. And of course, there is rock art sites that we can link with this material. So to contextualize this rock art, I work at the region scale with the geological prospection surveys to know where we can find some iron-rich rocks. On the stratigraphy with the material that was found in it, and obviously with the matter on the walls. So I don't know if you are familiar with the landscape and with the caves here. I just took what Diego gave me with the maps. So obviously there is a lot of sites and rock art sites here. I put the 4 caves I'm working on for my postdoc, because obviously there is too much for just 2 years of postdoc. So Diego proposed me to work on these 4 sites. They are in the valley of, I don't remember the name of the valley, but yeah, very close to Lake Itio, and in the same valley, and they are all painted. And I will go pretty fast on that because I'm not very expert with the painting of the cave, but this is the first one, Lumentia. In this one, the paintings are very thin, and I think it will be very difficult to analyze directly the painting on it. But the thing is, there is a lot of pieces of coloring material in the archaeological sequence, so it's very important to take this one into account, because there is a lot of material and it's a very good documentation of what it was used during the Palaeolithic and the Gravettian or Magdalenian period. So the second one, I didn't went there, but I can say of what I saw on the collection at the museum that there is a lot of coloring material too in the archaeological sequence. Kind of the same type I saw for Lumentia. The same for Ondaro. There is a less of coloring material, but still very nice and still at the same period. And Armenia. I'm sorry, I'm going fast, but it's not very easy for me to speak about this. So that is a graph that speak about the methodology I use. So here it's something about the geological reference I took in the landscape, and I do all this scale of analysis from the macroscopic scale. That is, describe the outcrops, describe the mineralogy of the iron-rich rocks, then to the microscopic scale with the ECM, EDS, and the description of the micromorphology of the minerals in the sorry, I lose my words. In the coloring materials. And I do the same, exactly the same, with the material in the archaeological sequence. I just try to be less invasive and less destructive with this material. So we used facility like ECMEDS or a facility in France at the Louvre, because they have some devices that allowed us to be less invasive. But I do exactly the same to have the same kind of information that could be comparable between the both archaeological and geological samples. And then for the rock art, it's kind of difficult because it's sensitive and we cannot be invasive. So the first is to use in situ analysis. It's important because it gives us a first level of information, but there is a lot of environmental input in the analysis that we need to take into account. And I prefer, when it is possible, to have micro sample of the rock art, because it allows us to take them in the lab and to do the same methodology that for the rest, for the archaeological and geological sample. So same thing, macroscopic information, microscopic information, and then when we can, we try to have the geological signature of all these materials to be able to compare it and to see and to say if it's correspond of what we saw with the macroscopic and microscopic information. It's kind of a panel of information, like a lot of information that we put together to discuss about the Paleolithic society. So, hope I'm clear. I lose no one. Okay, so I will just speak about the surveys that I made. Here it's a geological map of the Pays Basque. It's very nice because here in Spain you have a very good geological service that puts online the different geological map and with a very good precision. So I just have to take them, to put them in a GIS, and that's it, I can work. So here it's the result of my first surveys here last year in June. It was kind of difficult for me because it was my first time here. I didn't know about nothing about the geology here. It was very rainy and with a lot of vegetation, so I could see nothing. But now it's better. So I start the prospection, the surveys around Lequitio, and I could found around 6-7 points of iron-rich rocks where it was available. It was like at the outcrops and all along the river, like rocks that was moved by the river, and I found it until the beach. So it's kind of make me think about where it was available during the Paleolithic. And I think I am going to the end of the presentation with just what we did last year at Lumentia. We just went there to take a sample of powder of ochre on the ground. And here it's some pictures of during the surveys with the beach of Ogeia that I represent here, and this is a layer in the limestone where there is a concentration of iron between two layers of limestone, and this one could be a very good coloring material for painting. So it's the reason why I took it. So this is the end. I hope I was not too long and boring. And to conclude my presentation, I just wanted to show you all the collaboration I have beside this project to help me to do the analysis, the field work, and developing some methodology. It's mostly French institution, of course, because it's where I came from. But there is also an institution from Belgium, because there is a very good service of geology there that helps me a lot to understand how works the formation of rocks and everything. And here it's some pictures of what I did during my PhD. And these pictures, it's special because we are working in a new project to understand what's happening on the walls after the deposits of the coloring materials. So, thank you for your attention. If you have some question, I will be happy to answer it. Oh, no question? Oh, yeah.
For the geological samples, do you consider samples coming from actual excavations, from stratigraphic position? Do you consider samples coming from the floor of the cave? And if you consider both, do you treat them in a different way? In this multi-scalar approach you are applying, like if they are coming from two different scales, so one from the floor of the cave, maybe right below the paintings?
It's so nice question. We are trying to work on all the material they are in the cave, like you said, just above the paintings at the bottom of the panels, and also the ones who are in the stratigraphical sequence. We saw multiple cave where there is in the cave geological, like iron-rich rocks, directly available. And it is a good question because it could be what it was used to do the paintings. And yes, we are trying to study what's here. Is that okay?
Yeah, could you tell us the different kind of analytics that we can do in geological samples, archaeological ones, and after in rock art? I mean, this we cannot have the same resolution in all of them. So more or less, what kind of analytics are available for them?
I bring you here an example of what we can take on the field. It's a Raman. It's an example of the in situ analytical device. The precision of this is not very high. It's a compromise about the weight of the device, because sometimes the caves or the sites are have a very good access facility, are very easy to access, and it's okay. But sometimes you have to work in the nature, to carry all the stuff you need, all the gear to analyze. So this one is very light, but the resolution of it is not as good as we can have in the lab. So the analyzing spot, it's not large, but it's a millimeter scale, and it's pretty hard to target the exact point you want. But we have like a tripod to help us and stuff. So the resolution, it's not so bad. Actually, we are testing it because we just get it in the lab. So we are improving the methodology with it. But the Raman gave us information about the mineralogy of the samples and the rock art.
Sorry, what is this technique?
Oh, sorry, it's a Raman. 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 Sorry. No one knows what it is. I can explain it. It's quite simple. There is a laser in it, and you target the sample you want to analyze with the laser, and it excited the molecular link in the material, and you get back a response, a chemical response, and then we are able to analyze this response and to say like, oh, it's hematite, it's goethite, calcite, and so on. So it gives us a spectra. I don't know if I have one here. It gives us a spectra, and we have to interpret it. It's like it's an improvement method. Like we have a spectra, and we have to say like this peak is hematite, this peak is another mineral. So, but yeah, in situ, it's always difficult because there is never just the coloring material and the substrate. There is like biomineralization, and there is natural things that happen on the world that is complicated to understand. So this is all the same issues with the in situ analysis. We have the device that allows us to characterize the geochemistry, but it's the same. It's a compromise between the weight, the resolution, and it's a compromise, and it's a good way to start to analyze the paintings in caves before going to something more destructive or more invasive. So what we have, I think I have a presentation that I can show you. Sorry. Just to where it is. Because we have devices that allow us to characterize the mineralogy, and others that allow us to characterize the geochemistry. And it is very complementary. But if you want some good results, you need to go in lab. Do we have sorry. This is an example of what we can have like a result for geochemistry. Okay, this came from my PhD. So I had this result with the Aglaé. It's a particle accelerator from the Museum of the Louvre in Paris. It's a special device that is dedicated to cultural heritage and archaeological science and artifacts. It's completely undestructive and non-destructive and non-invasive. So it is the very high precision methodology that gave us a very good geochemistry signature of the sample. And you can put everything you want in front of this. They used to analyze like paintings, easel painting, but they also analyzed like silicates, rocks, or whatever. It's very easy to use. You just have to put your sample in front of it. It's done. The good thing with these devices, it's his precision, because you can have like a precision like I don't know how to call it in English. It's part per million. It's like very when there is like 1 atom of something, it can see it. And so you can have very good geochemistry signature, and you can use it on archaeological artifacts. That is the problem with the device we have in the Missouri University. It's very invasive and very destructive. The thing I was talking about in the first place, the neutron activation, when we put the sample in the reactor, we have to grind the samples into powder and to put them in the reactor, and then it's gone because it's too radioactive. So it's good for the geological sample, but not for the archaeological ones. And then I think I won't tell you about all the devices we have because it's too many. Actually, we can use everything the physics have as a method, but yeah, it's the one I use usually when I'm working on archaeological samples. Yes?
If I understand, most of your analysis are doing in the lab.
Yes.
And which techniques you use in the lab, apart segment?
Not so much actually, because the ECM EDS gives a very good result. Obviously, the sample we have for the Palaeolithic archaeological samples are very small.
With this technique, you have the atomic composition or the chemical composition of the sample, but not the structure of the sample.
Oh.
They give you, if you have iron, of calcium, of manganese, but you don't know which is the structure of this material, which type of iron oxide you have.
Okay, yeah.
So, I'm very surprised because at the moment there is several techniques for in situ analysis, non-destructive, like Raman, or X-ray diffraction, or fluorescence, which give you the same information and the best quality at the same analysis in the lab. So another question is that with this device, Raman, this is a very, very bad one. I mean, it's a very low resolution.
Oh.
You can have portable Raman fiber optic system with much better resolution, and you can do that in the in situ analysis. Okay, so from the point of view of the resolution and of precision, I think that it's necessary to know not only the chemical composition but also the structure of, for instance, the carbonate or iron oxide or iron manganese, etc. Okay?
I agree with you. Actually, I didn't speak about all the methodology. If we want to speak technique, this one is not very bad because the spot is pretty large, but there is something in it because there is 2 lasers. There is a program in it that improves the spectra. It's a very good one. It's very difficult to understand it because it's very small and it looks like a toy, but it's very good. And yes, in the lab I used other techniques, but with the archaeological sample and especially with the pieces of ochre, I tried to use like XRD, like X-ray diffraction. But the thing is, if we don't want to touch and destroy the sample, it's touchy because the orientation of the minerals make background signal very high, and we found that the best information is the mineralogy information, the morphology of the minerals, and when we add the geochemistry information, we have a very good sense of what we are analyzing. Obviously, the Raman is very good, and it's something I will use an archaeological sample, but it's a lot of methodology we had to put together, and it takes a lot of time. But I agree with you, we have to work on the structure of the minerals because it gives us an information about how the rocks was made and where we can find it. And it's something more to compare the geological sample and the archaeological one, for sure. Okay, Do anyone want to try analytical methods in your work or? No. But if you want, I bring you some samples of iron-rich rocks that I found this week around here, around more Lekitio, I think, this one. I choose three different ones, and if you want, I can show you how the device works, that you can have an idea of what we can do in sites. Okay, if you want, you can come around here and I will show you a bit. Oh. I probably have to change the battery. Oh yeah, you can take it, or yeah, as long as you put it in the same bag, it's okay.